Three, two, one, go.
Oh God. Okay, so I'm going to do some tutorial videos. I don't know where I'm in frame. I don't have the camera up right now. I want to do some tutorial videos on OpenGL and/or WebGL. That's my first note of business. Whenever I say OpenGL for the next however long these videos are, that means WebGL. Pretend they're the same thing. So these little recorded lecture things I'm doing are not like, I'm not going to reteach what's in the course content or anything like that. I'm just going to go over how OpenGL works, because that's kind of missing from the lectures right now. But I think to at least some extent, Sri does a decent enough job covering computer graphics concepts. We're going to talk about how to actually do them on the graphics card. So I guess to start off with, something that might come up in lecture, or probably comes up in lecture, is the idea of a pipeline. This comes up a lot. I've got a little, where the heck did I put it? Where did I put it? I'm also kind of winging these videos, so if they're weird, you'll survive. Getting started, triangle. So, that one. There we go. Okay, so the idea of a pipeline probably comes up a lot in the early lectures of graphics, or at least a few times in the early lectures of graphics. And you may have seen a diagram that looks something kind of like this. I've heard it comes up in lecture, but it maybe doesn't go into a lot of detail. So I'm going to draw, this is the whole process. In OpenGL, we can control these three blue ones. In WebGL, we control the vertex shader and the fragment shader. So I'm going to switch back to the camera and start, draw that over here. So we've got as inputs, we've got vertex data, and that comes into this box called the vertex shader, and then that goes into the fragment shader. So it's kind of, you see this a lot, but I'd like to kind of stress about making sure you understand like what it is that's actually happening here. And then so the fragment shader then, spits out, you get your little, your fancy triangle, yay. So what's basically happening here is that these shaders that you write are little C functions, or C++ or whatever. They're basically C functions. And together, they form, they form a program. That's what the pipeline is kind of the graphics card terminology for it. Graphics rendering is done with a pipeline, and the OpenGL implementation of a pipeline, when you make your own pipeline to customize how you want your vertex data to be rendered, it's called a program, and it's made up of these two. And the names of these, they're based on, basically you can think of it, they're based on what they're named on, named after what they spit out. So if it's not entirely clear, the vertex shader takes in, the Learn OpenGL one had a little array here. This takes in arbitrary data, like literally anything you want, and it spits out one thing, a vertex position, which is a vec4 because of homogeneous coordinates. Well, that's part of lecture theory, whatever. Spits out some 4 numbers, whoop, and that's all it spits out. Well, almost all it spits out, because the other thing it might spit out is more arbitrary data for the next stage in the pipeline. And then this stage in the pipeline spits out one more arbitrary piece of data. At least all we'll ever see is one piece of data, which is another vec4, which is, this case we have x, y, z, w, and RGB, a. The reason that we do this, I want to guess, I'm going to single you out. I have an audience in here. Why do you think we have them done in steps like this?
Huh?
Why is the vertex shader and fragment shader done separately? It does all of these, and then it does all of those.
That's an excellent question.
the
Is it because the fragment shader it requires information from the vertex shader?
Yes, but the more high level than that, the thing that I'm getting at is that, it comes up in assignment theory questions later in the course, is that the GPU loves doing crap in parallel. So this runs not once per object, not once per triangle, once per vertex. It spits out one vertex. So if you want to draw, say I have some square which is made of, technically 6 vertices, right? It's made like this. Doop, 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 doop. I don't remember if those are in the right order, but whatever. To render this, the vertex shader needs to run 6 times. Each of these vertices has some number of attributes associated with it. It might have literally anything, junk data 1, and that's just some array that's associated with it, and then it has more junk data. Whatever your vertex shader needs. If this is a really complicated program, it might take a bunch of data. That gets fed into the vertex shader part of the pipeline, and it spits out one position. And then any more data that the fragment shader might use. And then the fragment shader needs to get run once for all the pixels in here. There's a part that happens in between that called rasterization, and the graphics card worries about that, where it figures out what pixels do what. That's also part of lecture. But because it's separated like this, it means that we can run the vertex shader say we had 600 vertices, we could run it 600 times all at once because the graphics card loves doing things in parallel. Then say that our shape ends up covering, 600 by 600, whatever 600 squared is. That's 3.6 million or something like that. Then we can run our fragment shader 3.6 million times, more or less at once, because we can compute all the outputs of the vertex shaders into the inputs to the fragment shaders all at once. So I think that's I also might be, grossly simplifying the theory of how graphics cards do rendering, but that's kind of an overview of what you can think about it doing when you're doing OpenGL or WebGL. So that's something that I've seen people kind of confused about in labs, and I'm kind of hoping to address here. Maybe if I'm getting a little rambly, I kind of want to clarify at the end here is that arbitrary vertex data, that's what you'll put in your buffers or wherever, and you define what you want as vertex data using attributes, aka all the properties of each vertex. Each vertex has attributes, so that needs to be muted. And then those go into your fragment shader. I saw people in lab going, oh, what's a vertex attribute? And it wasn't always entirely clear that the vertex shader was running once per vertex and spitting out one vertex. So, yeah. What's next?